Have you ever looked at a rainbow-colored parrot, a flashy blue lizard, or a fish that glows neon pink and then looked at your dog or cat and wondered, why are mammals so brown? I mean, sure, you get blacks, whites, and grays, but where are the purples, the bright greens, the shocking pinks? Most mammals seem to have missed the memo on vibrant colors. So, what's the deal? Why don't we see squirrels rocking a majestic violet coat? Well, it turns out there are a few big reasons. First, let's talk about how color is even made in the animal kingdom. Animals generally create color in two ways, with pigments or with structures. Pigments are like natural dyes inside the skin or fur that absorb and reflect light. Think of it like paint. Structural color is different. It's created by microscopic shapes and patterns on an animal's surface, like on feathers or scales. These tiny structures bend light to create dazzling, iridescent colors, like what you see on a peacock's feather. Here's the catch. Mammals aren't great at using either of these methods. While other animals have a whole palette of pigments to work with, carotenoids, porphyrins, you name it, mammals basically have just one, melanin. Yep, that one pigment is responsible for all the shades of brown, black, and reddish-brown you see in mammal fur. And when there's no melanin, you get white like on a zebra or a panda. What about structural color? Well, our hair just isn't built for it. Feathers and scales are complex structures that can form the tiny, light-bending patterns needed for iridescence. Hair, on the other hand, is much simpler. It can't create those nanoscale patterns. Think about one of the most colorful mammals, the mandrill, with its bright red and blue face. Those vibrant colors are on its skin, specifically in places where there's no fur. And what about sloths that sometimes look green? That's not their fur color. It's actually algae growing on them. So why did evolution shortchange mammals on the color front? To answer that, we need to go way back in time to the age of dinosaurs. When mammals first appeared, they weren't the top of the food chain. Dinosaurs were. To survive, early mammals adopted a new strategy. They became nocturnal. For over 100 million years, our ancient ancestors lived their lives mostly in the dark. And what is the best color to wear at night if you do want to become a dinosaur's midnight snack? Dark colors, of course. Researchers have looked at fossils of ancient mammals and found that they were all shades of brown or gray. In a world of shadows, being brightly colored would have been a death sentence. Any splash of color would have been quickly eliminated by natural selection. Okay, but the dinosaurs went extinct 66 million years ago. Since then, mammals have exploded into over 6,000 species, and many are active during the day with no natural predators. So why are they still so drab? The answer might be in their eyes. To become experts at seeing in the dark, early mammals sacrificed something important: their color vision. Most mammals today are what we call dichromats. This means they only have two types of color-detecting cone cells in their eyes, unlike humans and other primates who are trichomats with three types. Being a dichromat means you can't see colors like red, orange, or purple. The world looks a lot less vibrant. Think about it. What is the point of being a dazzling color if the animals you're trying to impress, communicate with, or hide from can't even see it? For most animals, color is used for things like attracting a mate, warning predators that you're poisonous, or camouflaging into the background. None of that works if your audience is colorblind to your specific shade. Some mammals have even turned this lack of color vision into an advantage. A tiger's bright orange coat looks incredibly obvious to our trichromatic eyes against the green jungle. But to its prey, like a deer with dichromatic vision, that orange looks green, making the tiger perfectly camouflaged in the tall grass. It's genius, really. So instead of using vibrant hues, mammals got creative. They use patterns and high contrast to send signals. A skunk's bold black and white stripes are a clear warning to predators. Stay away, or you'll regret it. The African wild dog has a unique white tip on its tail, which is thought to help the pack members signal to each other during a chaotic hunt. And the Indian giant squirrel, with its high contrast mix of black, brown, and orange-yellow, might be using that pattern as camouflage against different types of predators in different lighting. Since mammals found other ways to communicate and survive without a full spectrum of colors, there hasn't been a strong evolutionary push to get that vibrant vision back. The few exceptions, like us primates, evolved full color vision for very specific reasons, like finding ripe fruit in a green canopy. It's no coincidence that the most colorful mammals, like mandrills and golden snub-nosed monkeys, are also primates with excellent color vision. They can actually see and appreciate their own flashy colors. But hold on, the story doesn't end there. It turns out mammals might be a bit more colorful than we give them credit for. We just can't always see it. Recent studies have found that many mammals, from platypuses to wombats, actually fluoresce under ultraviolet light. We can't see UV light, but some other animals can. So they might be having a secret light show right under our noses. And there's more. Researchers have also discovered iridescence, that shimmery, color-changing effect in a few species of tropical rats. One scientist had a light bulb moment when she opened a museum drawer and sunlight hit the preserved furs at just the right angle, revealing a hidden shimmer. We don't know yet if this iridescence serves any purpose, but it proves there are still mysteries to uncover in the world of mammalian color. So while you might not see a hot pink bear anytime soon, the next time you look at a mammal, remember their boring brown coat is actually a story of survival. It's a tale of hiding from dinosaurs in the dark, of adapting to a world seen in muted tones, and of finding clever new ways to communicate. Mammals aren't dull, they're masters of subtlety. And who knows what other hidden colors we have yet to discover. Thanks so much for watching. If you found this as fascinating as I did, hit that like button and subscribe for more deep dives into the weird and wonderful world of animals. See you next time.